Hey everybody, today we're going to talk about scatter plots. We're going to talk about the different types of correlations that you can see on a scatter plot. This will be the first day that we talk about them. Alright, basically when you're looking at a scatter plot, it's just going to be a graph that represents two different types or two different sets of data by displaying them as ordered pairs. So every dot that you see on your scatter plot is going to represent some sort of ordered pair from your data. And you can use your scatter plots to find trends in the data. Okay, so looking at our three different types of scatter plots that we could end up with, this first one here is going to represent a positive correlation because it goes uphill to the right. Okay, our second graph is going to represent a negative correlation because it goes down to the right. Now, if you remember back from slope, it's very similar to slope. If the slope goes uphill, it's positive. If the slope goes downhill, it's negative. Same thing with correlation. If it goes uphill, it has a positive relationship or correlation. If it goes downhill, it has a negative correlation. And then finally, this last one, scatter plot, doesn't really have any trend to it, so we're going to say that this one has no correlation. And those are the three different types of scatter plots that you would see. Okay, so let's actually make a scatter plot of this data. I'm going to get our graph drawn here and then start plotting some points. Alright, so here's the general base for my scatter plot, and now I'm just going to start plotting points. So my first point is going to be with $10 spent and 2.5 gallons bought. So I'm going to go over 10. Now I just represented each hash mark as $1. So I'm going to go over to 10. And then I'm going to go up to 2.5, which is going to be right about there. My next one's going to be at 11 and about 2.8, so just right above where I made my last one. Doesn't have to be completely perfect, just get it in the general vicinity. My next one's going to be 9, 2.3. Like I said, you're just plotting points just like we've done this before. Your next one is going to be 10, 2.6. 13, 3.3, 5, 1.3, 8, 2.2, and then finally 4, 1.1. Okay. So that's about what your scatter plot should look like, something like that. It's not going to be a perfect line because that's the idea of a scatter plot. Okay, and just to recap, where I got all these points from was right here. So this was the point right here, 11, 2.8. The 11 was the X value, and the 2.8 was my Y value, my gallons bought. Okay, and I just plotted all these points here on my scatter plot. And what type of relationship does this scatter plot show? Well, it shows a positive relationship or a positive correlation because it goes up to the right. Okay. We can also look at something and look at a word problem and not even need to draw ourselves a graph and basically be able to predict what type of relationship it would be. So if we consider the population of a city and the number of letters in the city name, would you expect a positive correlation, a negative correlation, or no correlation between the two sets of data? Okay, well, there really is no relationship between the population of a city and the number of letters in the name. You really don't choose where you live based on the size of the name of the city. So this would be no correlation. And your explanation would be just because of what I just said. You don't really choose a city based on the size of its name. Okay, and then finally we have something called a causal relationship. Okay. Okay, this is basically when a change in one quantity actually affects the change or causes a change in another quantity. Okay, so and also a correlation does not always imply causation. Okay, and we'll look at one of those examples here below. Okay, so in the following situations, is there likely to be a correlation? And if so, does the correlation reflect a causal relationship? Okay, so the number of loaves of bread baked and the number of flour used. Okay, yes, this is going to have a correlation. Okay, it's going to be a positive correlation. Okay, because as the number of loaves of bread baked, you're also going to use more flour. So both quantities are going to go up at the same time. Okay, so yes, it's a positive correlation. And it's also going to be a causal relationship because as you bake more bread, the flour goes up. Okay. All right, the number of mailboxes and the number of firefighters in a city. Okay, this is most likely going to be a positive correlation. Because as because as the number of people in the city increase, the number of mailboxes also go up. Because you have to put more mailboxes for your population. Okay, but this is not going to be a causal relationship because just because there's more mailboxes doesn't necessarily mean there's more firefighters. Okay, so these mailboxes could be for anyone in the city. They don't necessarily need to be for firefighters. So that's why it's not a causal relationship. Okay, but on the other hand, it's a positive correlation because as the number of firefighters in the city increase, the number of mailboxes will go up. Okay, next one, the amount of time you study for a test and the score you receive. Well, this is going to be a positive correlation. And it's also going to be a causal relationship. Okay? It's a positive correlation because they both go up at the same time. You study more, your score goes up. And it's a causal relationship because if you, the more you study, the more your score goes up. And if your score goes up, you probably studied more. Okay, and then the last one, the shoe size and the salary of the teacher. There is no correlation here. It does not matter what your shoe size is. Teachers do not make more money. All right, and that is the idea of correlation. So for tomorrow, come up with an example of a relationship that has positive correlation. Okay, and we will see you tomorrow.